In the first video I explained how the moon was ejected from the Earth, and as a result of its momentum in space it went in a line on the surface energy shell so that its total energy remained constant. When it has traveled about a quarter of a way around the ball, it had gone from the kinetic energy dimension of the energy shell to the potential energy dimension. This has three dimensions. Energy has three dimensions, just as space does. And this direction here, this dimension is kinetic energy, and this one is potential energy. So that it traveled up tethered, so to speak, by the limitation that the total energy cannot change, and the energy became entirely potential. And then it traveled down the other side of the energy shell, and in space, of course, it went straight up and straight down, and you would expect that it would crash back into the Earth, just as when we throw something into the air, it crashes back into the Earth unless we catch it. If I throw this up and catch it, it goes up and comes back. But while it's actually in the air, separated from the Earth, it actually is in an energy shell. But in the case of the moon, it went up much further and much more rapidly, 24,900 miles an hour, and traveled a distance of twice its present distance from the Earth. The moon would take, at that time, would have taken about 2.5 days to return to the Earth. And it would have returned if it were expelled from the Earth at a tangent, which probably was if it was caused by an asteroid. It would have returned to the other side, so to speak, of the Earth and crashed there. But there's another phenomenon that is associated with what we call precession, in which elliptical orbits, which is what this is, a very, very narrow, highly eccentric elliptical orbit, they tend to become circular. It's a more efficient way in which the energy can be maintained. And so it actually, in 2.5 days, and having gone that great distance of nearly 500,000 miles, it stood a chance that it would have actually arrived back at the Earth further away from it, and to either give a glance and blow or even completely miss the Earth, and that's what it must have done. So the moon then, having gone to that great height, twice where it is now, come back past the Earth and gone again in the other direction, and it then began this elliptical orbit. The process I spoke about associated with precession, that would then cause that orbit to become more circular as time went on, and after 4.5 billion years it has become almost circular. Eventually it would become circular. But there are other factors, such as other bodies, such as the Sun, that will cause it to be distorted. The energy shell still remains spherical, because the energy between the Earth and the Moon cannot change, and this is what this shell represents. But the orbit might become distorted due to other bodies, in which case when the Moon travels a little further from the Earth, it will slow down, and if it travels a little nearer to Earth, it will speed up, but its energy will remain constant. That is a sum of its potential energy and its kinetic energy. Well, in the next video I'll talk to you about the planets and the Earth as to how they were formed, and give you some other equations that I used in this calculation. So this is the end of video 2. Thank you for watching.